geometry. First, let's observe at what are different types of spread look like. The most commonly used is a centrally symmetrical spread. The source is located in the center, and both directions from it receivers record information. The number of channels that simultaneously record information from a given source varies. Typical values for 2D is 24, 48, and 96. 24 channels means that 12 receivers on both sides of the source will record information from it. Even if more seismic receivers are already installed in the field, the rest are turned off at the time of excitation. The step between receivers in Russia is most often 25 to 50 meters. The flank spread is different in the fact that all receivers are located on one side of the source. Therefore, it's possible to discover deeper horizons. In addition, the spread can be asymmetrical when the number of receivers from different sides are not the same. Here we have only one spread shown. When shooting, this spread shifts along with the source. Let's take a look at a different example. In this case, the distance between the receivers and the sources is the same, and the sources are located between the receivers. The yellow color shows which seismic receivers register information from the source that is detected as orange. After we move the next position of the vibrator, the arrangement will shift along with the source to preserve some symmetry. All receivers remain in place, but some of them, indicated in black, are turned off at the time of shooting the source. Often the source on the edge of the profile will have an asymmetrical and then flanking arrangement due to the limitation of the profile. For example, for the last source point on the right, 5 channels will work on one side and 0 on the other. As you can move the source closer to the center of the profile, the number of channels on one side increases until it reaches 5. Sometimes the receiver line is taken out of the source line in order to how it's shown on the left side of the profile, so that there can be the same spread everywhere. It depends on the planning and requirements of the customer. Fold is the nominal value of summation traces falling at one CMP point. It will have constant values in the center of the profile with deviations in case of displacements in receivers. When approaching the edge of the profile, the fold will gradually fall. In this case, it will decrease by one value, since we will lose one trace. At the last example, the edge values of the fold will be 5, the central 10. The step between the source points is most often equal to or greater than the step of receiver points by 2 times. This is the most convenient when processing data. Sources can be located directly at the receiving points or in between them. It depends on the types of sources and receivers. Ultimately, it won't affect data. The source step is almost never less receiver step. It's much more profitable to put more receivers than to make more excitation in case of an explosive source and the need to drill wells. The size of CMP areas in 2D seismic exploration is most often defined as half the nominal step between the receivers. But if the shots were more frequent than receivers, then the size of CMP sites will be determined by half the step between shots. A significant problem in the planning of the acquisition geometry are natural and artificial obstacles. Such obstacle can be a lake, a swamp, a man-made object, a private territory, a reserve, etc. Most often they can be bypassed. In other words, the profile line can change directions. Sometimes receivers stay on the main course of the profile and the source. This makes it more difficult to process and interpret, however, than simply not having seismic works on some area. Removal often occurs according to a plan. For example, the displacement can only occur perpendicular to the profile line and to the nominal step between shots. In this way, the fold is preserved and cost of the loss of near distances and an increase of the midpoint distribution, which somewhat reduces the efficiency of summation. Sometimes it is impossible to bypass obstacles, for example, a river. In this event, we can simply we may just not make excitations in this area, but then our fold will drop. The customer will often be dissatisfied with this outcome. After all, decreasing fold means an inevitable drop in accuracy compared to the rest of the data. Therefore, often those shots and receivers that had to be skipped are placed and shot and after the restricted areas. By increasing the pitch of the shots and receivers there. As a result, the number of bases per CMP point is maintained or reduced within tolerance. This, of course, does not completely replace the regular profile. After all, this way at the CMP points with missed sharp points, we lose short offsets. And the farther away the source is from the receiver, the greater the chance of absorption, loss, prevalence of noise, etc. In addition, the upper part will be lost in the section. However, if it's not possible to bypass the obstacle, this is the only way to maintain the quality of data. What can be an obstacle that makes the regular position of sources and receivers change? First of all, it's a water obstacle, a lake, a river, a swamp, driving into which the equipment can get stuck. It also be a sharp change in the terrain, for example, a steep slope or a hill. The technician may not be able to drive on it or may not be able to stand steadily to drill or excite with a vibrator. It can also be a raven. The receivers usually can be installed on the banks and at the bottom of the raven. The sources, however, will not be able to leave the raven if its banks are too steep. Man-made or industrial obstacles such as power lines, roads, oil and gas pipelines, villages, can be a big obstacle as well. These can also be man-made obstacles from the equipment already available in the area used for exploration and production of hydrocarbons. Prohibited areas for blasting or vibration work, including both security zones and private areas, the owner of which did not agree to conduct seismic surveys on his territory.